Hi everyone, I'm Puan Hanisa. Okay, today I'm making video for the next part of trigonometric ratios. Okay, the previous video is 5.1 part 1 about the subtopic 5.1 sine, cosine and tangent of acute angles in right angle triangles. In the previous video, I taught you how to identify the opposite side, adjacent side and also the hypotenuse for a right angle triangle. So if you cannot remember how, or you don't know how to find to identify all the sides, you may watch the video. Okay, because for today I'm going to teach how to find the trigonometric ratios. Okay, we have three trigonometric ratios: sine, cosine and tangent. Okay, the sine, cosine and tangent of acute angles in the right angle triangles, okay, we can find it using this formula. Okay, the first one is sine. Sine is the opposite over hypotenuse. Cosine is adjacent side over hypotenuse. Tangent is the opposite side over adjacent side. Okay, or usually I will teach my student using the shorter formula as, okay, O H C A H T O A. Okay, so ka toa, so ka toa. Some student like toa ka so, no problem. Okay, if you want to use ka so toa also can. Okay, but you must know that so here means sine or equals O opposite over H. Ka is cosine equals to adjacent side over hypotenuse. Tangent is equal to opposite side over adjacent side. Okay, that's why you must know how to identify the sides of the right angle triangle. Okay, I revise again lah. Okay, if you have right angle triangle with 90-degree, opposite with the 90-degree is the hypotenuse. And if the acute angles, okay, is here, okay, then the opposite is, okay, here, while the adjacent will be here. Okay, if, okay, if the angle is here, okay, this will be still H, but the opposite will be here and the adjacent is here. Okay, okay, now I hope you can see the difference based on the angle. Okay, based on the angle here. Okay, so these are the formula. You please remember. Okay, so ka toa toa ka so toa. Okay, it's up to you which way you want to remember, as long as you must remember. Okay, so now let's look at example. Okay, complete the following table based on the diagram on the right. Complete the following table based on the, okay, sorry, it's not on the right, it's below. Okay, because I crop it. Okay, so this is the right angle triangle. You have angle X and you also have angle Y. Okay, Y and X and Y in the triangle. Okay, so the question asks you to find the value of sin X, cos X. Sin here refer to sine, sine, cos, tangent. Okay, for X, and also sine, cos and tan for Y. Okay, so remember the formula to find sine is so, okay, ka tua. Okay, remember? And then you must be able, you must be able to you must be able to identify the side of the triangle. Okay, you must be able to find the side. Okay, I write here the formula: SOH AH DOA. Easy to remember, right? So katwa. Okay, for x, okay, angle x is here. This is always be hypotenuse because opposite. Okay, now the opposite for x is here, and the adjacent for x is here. So sine x is, okay, sine x equal to opposite over hypotenuse. So the opposite is QR over hypotenuse is PR. So the answer here is QR over PR. Okay, now about cos. Cos x is, okay, cos x is adjacent over hypotenuse. So the adjacent is, look at the diagram, adjacent here you label already PQ, and the hypotenuse is PR. So PQ over PR. Okay, what about tan? Tan x equals to opposite over adjacent. So the opposite is QR over the adjacent is PQ. So QR over PQ. Okay, so next for y. Okay, for y, this is the angle y. So the opposite is here, the adjacent is here, and opposite to the 90 degree is hypotenuse. Okay, so sin y equals to the same formula, O over H, so equals to PQ over PR. Okay, so this is PQ over PR. Okay, and then for sin cos y equals to A over H, where A is the QR and H is the PR. So QR over PR. Okay, now for tangent tan y is O over A, so PQ over QR. PQ over QR. Okay, see, can you see it? Okay, use the formula to find the sin cos. Okay, next example. Okay, state the sin theta of the sine of theta in each of the following. Okay, okay, so for question A, angle sine theta is equals to opposite over hypotenuse. Okay, hypotenuse opposite adjacent. So opposite is AB, while hypotenuse is AC. Opposite over hypotenuse. For question B, okay, sine theta is equal equals to opposite x over hypotenuse is y. Okay, right, easy, right? Okay, next. State the cos of theta in each of the following right angle triangles. Cos of theta. So, question A, cos theta. Okay, remember cos theta, ka, adjacent over hypotenuse. So, equals to, okay, this is the theta, adjacent is this one, hypotenuse is this one. So, AC over BC. Okay, for question B, theta adjacent over hypotenuse. Okay, so cos theta equals to y over z. Okay. Okay, next question. Okay, what about this one? You check first. Okay, find your answer. Okay, formula for tan is toa. Okay, so answer for A. Okay, you label first. Hypotenuse, adjacent, opposite. Okay, this one, hypotenuse, theta is here, so adjacent, opposite. Okay, so for question A, tan theta is OAC over adjacent is AB. Okay, question B, tan theta is opposite. Opposite is x over A. A is z. So x over z. Toa. Okay, OA. Okay. Next. Okay. Settle to find cos and tan. Okay. In this video, I don't give you the calculation. Okay. I'm just telling you how to find the sin cos tan. Okay. Now discuss the value of the sine, cos and tan based on the size of the acute angle. Okay, the larger the size of the acute angle, okay, the larger the size of the acute angle, the larger the value of sine and its value approach 1. That's mean, okay, acute angle is angle less than 90 degree, right? Acute angle is angle less than 90 degree. Okay, the if the value of the acute angle become larger, okay, from this value to this approach 90, the value of sin also increase. Okay, from 0 until 1. Okay, that's mean when the size of the angle is increased, the value of sine also increase, and the maximum is 1. Okay, the smaller size, the smaller the value of cosine and its value approaches 0. Okay, different with cosine. Okay, when the angle increase in size, okay, the value of cosine will be smaller, and when it approach cos 90, the value of cosine will be 0. Okay, and for tangent, the larger the size of the acute angle, the larger the value of tangent. Okay, that's mean when the size of the acute angle become larger, the value of tangent also will be larger. So this is the conclusion, the tips. Okay, sin theta is equal to 0, sin 90 is equal to 1. That's mean from 0 to 1. Okay, when the angle is 0 to 90, it approach 1. Okay, this 0 degree, this is 90 degree. Okay, so from 0 to 90, the value of sin increase until it become 1. While cos 0 is 1, and then when the angles become larger, it become cos 90 equal to 0. While value of tan, when this is 0, it is 0, and then when the value of acute angle increase, okay, the value of tan also increase until infinity. Okay. Okay, summary. So for this video, I taught you the formula of SOHCAHTOA. Remember, SOHCAHTOA, and also the relationship of the size of angle with the value of the trigonometric ratios. Okay, but okay, now I want in the summary I want to show one more example about finding the value. Okay, finding the value of sin, cos, and tan. Okay, for example, I have a right angle triangle here. Okay, let's say this is 8.5 cm. The length of this 10.6 cm. Okay, I want you to find the value of sin theta. The theta is here, sin theta. Find the value of sin theta. So the value of sin theta is opposite over hypotenuse. So from this theta, you know the opposite is this one, the hypotenuse is this one, so equals to 8.5 over 10.6, so equals to 0.802. Okay, that's how you find the value. Okay, another example involving cos. Okay, let's say you have a triangle like this. It's 90 degree. Here is 10 cm. This is theta. This is 14 cm. Okay, find the value of cos. Okay, so cos theta equals to okay, a over h, right? So a is this one, h is this one, so 10 over 14. So you simplify, it become 5 over 7. Okay, it's better you give answer in fraction, more accurate, but in simplest fraction. Okay, now example for tan. Value of tan. Okay, let's say you have a triangle like this. Okay, this is the 90 degree. Okay, this is 13. This is 5 cm. 5 cm. This is theta. Okay, so tan theta equals to opposite. Okay, 90 degrees here, so this hypotenuse, this is opposite, right? So 5 over adjacent. Oh, adjacent, what is the value of adjacent? Okay, so for this case you must use Pythagoras theorem. Okay, I redraw because the diagram is so ugly. Okay, like this. Better, right? This is 13, this is 5. Okay, using Pythagoras theorem, to find the length of this is 13 square minus 5 square root answer. Okay, so equals to 12. Okay, so the length of this is 12. Okay, so 5 over 12. So the answer is 5 over 12. Okay, so I hope you can understand and don't give up. Bye.